Hello guys, welcome back to today's class where we'll be looking at another question on the remainders theorem. In this question we'll be looking at it is a more technical question that requires optimum concentration and understanding. Why? Because in this case, in your polynomial, you'll be having two unknown values. That is, you'll be having a particular unknown value A and another unknown value B. Now, we'll be asked to do for both of them, but then with two scenarios. That is, we'll be asked to do for them with two cases. That means we will look at it when it's divided by a particular divisor and then when it's divided by that divisor. So understanding of this concept is very important. That means the previous examples that I've done need to be understood explicitly before we can actually say we want to come to this. So if in any way you have not perfected the art of the basics that we have done, please make sure you have done that before you do this. Now, what we will be doing here will be just applying the idea of simultaneous equation to actually solve a question on what? On what? On remainders theorem. Okay, in this question, we are given that f of x is equals to ax cubed minus x squared minus 5x plus b, where a and b are constants. Full stop. Find the value of a and b if a remainder 36 is gotten when f of x is divided by x minus 2, and the remainder 40 is gotten when f of x is divided by x plus 2. Now, if you look at this, you see you have two cases. You have when the divisor is x minus 2 and the remainder is 36. That's the first case. Then the second case, when the divisor is x plus 2 and the remainder is 40. So how do we go by this? How do we attack this? So first of all, you bring out, as usual, you bring out your parameters, bring out the function, that is the polynomial. You have ax cubed minus x squared minus 5x plus b. And then we have two cases here. The remainder, in the first case, the divisor is x minus 2 and the remainder is 36. We have another case here. The divisor is x plus 2 and the remainder is 40. And then remember that we're looking for a and b. So first of all, using remainders theorem, we recall that what from remainders theorem for the first one, in the first case, d is x minus 2, the remainder is 36. I can easily say that what x minus 2 here is equated to 0, where I now have my x to be 2, and then I substitute it into the polynomial f of x, and then I have a into x cubed, where x is 2, minus x, that's 2 squared, x squared, minus 5x, of which our x in this case is 2, plus b. And then we know this is equals to the remainder. So I can call this one divisor 1, remainder 1. This one is divisor 2, remainder 2. So our R1 here is 36. So equating this, I have 8a minus 4 minus 10 plus b equals to 36. Breaking this down, you have 8a plus b equals to 36 plus 14. Because if you look at this, minus 4 minus 10 will give you minus 14. And when you take it to the other side, it becomes plus 14. And I can say 8a plus b is equals to 15. If you look at this, you realize we have a and b that are unknown. That is, we have two unknown values in this equation. So obviously, we know that this will be an equation 1, that will still need an equation 2, because we have seen two variables, and then we need two answers. So anytime you see two variables in an equation like this, it means we need two equations to get two answers. So we have gotten the first equation, we definitely know we need to derive another equation that will solve with it simultaneously to give us our values of a and b. So for the second case now, this is for the second case of divisor and remainder. I know for my second case, that is my d2 in this case is x plus 2, and my remainder 2, I can now use this one. I'll say x plus 2 equals to 0, and then I can say my x here will now give me minus 2. Okay, since I know this, I will just equate it into my polynomial f of x, and then say my a. So instead of 2 here, this one will be minus 2 now, instead of x cubed minus minus 2 squared minus 5 times minus 2 plus b equals to 40. So here I'll have minus 8a minus 4 plus 10 plus b equals to 40. Moving forward, we have minus 8a plus b equals to 40 minus 6. As we realize that 10 minus 4 here will give us 6. When you take it to the other side, it gives us 40 minus 6. So this will become minus 8a plus b equals to 34. Of which, by multiplying through by minus, you can make this become 8a minus b equals to minus 34. So minus and minus here will give us plus. Minus and plus here gives us minus. And then minus and plus gives us minus. So this becomes our equation 2. So since we have equation 1 and equation 2, we know we need to solve them simultaneously. For equation 1 is 8a plus b equals to 50. Equation 2, 8a minus b equals to minus 34. So we can solve using the elimination process of solving simultaneous equation. The elimination method. Using the elimination method, I can easily subtract my equation 2 from equation 1 in such a way that my 8a minus 8a will cancel out and will give me 0. And then I'll have b minus minus b, which will give me plus 2b equals to 50 minus minus 34. Then give me 2b equals to 50 plus 34. Then my 2b here will now be 84. It means my b here will now definitely be 84 divided by 2, where my b will be 42. So I've gotten my b to be 42. I can as well get my a. So by substitution, I know that 8a plus b equals to 50. 8a plus b equals to 50. So since b now is 42, I can say 8a plus 42 equals to 50. Then I can say 8a equals to 50 minus 42. I can say 8a equals to 8. I can say my 8 here is 1. I've gotten my a and I've gotten my b. So I've gotten my a and I've gotten my b. I can as well now remember that therefore the polynomial f of x is now, that means a is equals to 1 is 42. So the polynomial f of x will now be, since it used to be ax cubed minus x squared minus 5x plus b, ax cubed minus x squared minus 5x plus b, ax cubed minus x squared minus 5x plus b. B in this case is now 42. So this is our, and then these are our answers. So this is where we call it a day on, remainder theorem. So do well to solve more questions so you can actually master the art of polynomials, that is the addition, the subtraction, the multiplication, factor theorem, division, and as well the remainder theorem. So see you next class. Have a nice day.